Today, lesson 35C, basically an extension of what we started yesterday, the beginnings of 0 as an exponent and negative exponents. So let's get started. Write an exponential form using positive exponents. Well, this is what we started with yesterday, and so we should clearly know that that is 1 over 4 to the 4th power. Now, another way of looking at this, and this is extending on the pattern that we were looking at when we were trying to discover what 0 is as an exponent and negative exponents look like, we're going to start with that approach. So another way of looking at that previous problem is we can think of it as 1 times 4 to the negative 4 power, which then is 1 times 1 over 4 to the 4th, which is 1 over 1 times 1 over 4 to the 4th, and that, of course, gets us to 1 over 4 to the 4th. Now, the reason why I'm doing that is because sometimes we're multiplying other values times something with a negative exponent. So here's what I mean. If I have 3 times 4 to the negative 4, well, if we use that same kind of thinking, that is 3 times 1 over 4 to the 4th, which is 3 over 1 times 1 over 4 to the 4th, which is 3 over 4 to the 4th. And much like all of the things that we've been dealing with the past 3 or 4 lessons, we're trying to quickly see the pattern in what is happening here so that we wouldn't have to list every single one of those steps. In other words, what I am saying is this. We should be able to jump straight from here to here. Okay? All right. So we've already done that. So what would 2 times 4 to the negative 4 be? Just tell me, please, quickly. 2 over 4 to the 4th. We know that this is going to be 3 over 4 to the 4th. We already did that one. We should know that this is going to be 4 over 4 to the 4th. Now, of course, we can simplify this one. I suppose that we could have simplified this one as well. We're not worrying about that right at this second. We're just trying to see what's happening here. 5 times 4 to the negative 4th, 5 over 4 to the 4th, and so on. Now, in the next part of your notes, you have a whole bunch of them with 7 to some negative power. Could I get you to do all of those? Now, this is basically a lead-in to what's happening in the rest of today's lesson. Of course, all of those should look like this. 1 times 7 to the negative 4 is 1 over 7 to the negative, or 1 over 7 to the 4th. 7 to the negative 4 times 2 is 2 over 7 to the 4th. Commutative property says it doesn't matter which order you go in there. But 7 to the negative 4 times 3 is 3 over 7 to the 4th, and so on. All right, so let's go to the back side of your notes. Quickly do 1, 2, and 3. All right, so it's obvious that number 1 is 2 over 4 to the 4th, and number 2 is 5 over 3 to the 2nd, and number 3 is 6 over 3 to the 5th. However, we really should do a little more simplifying in number 1 and number 3. And the reason is because we have common factors between the bases. So let's go a little bit further with number 1. So we have 2 over 4 times 4 times 4 times 4. And then, of course, from there, we have a common factor of 2 here and a common factor of 2 there. And so that really will simplify to 1 over 2 times 4 to the 3rd. Now, I want you to use the same sort of thinking to simplify number 3. So could I get all of you to simplify number 3? And in number 2, there's nothing we can do because we don't have any common factors between the bases. There isn't a common factor other than 1 between 3 and 5. So all of these, and I took what writing I had up there off for number 1, but all of these, we're basically writing them in exponential form, but in simplest exponential form. So as far as number 3 goes, we end up with 6 over, and then 3 times 3 times 3. We have 5 of those 3's. And then, from there, we have a common factor of 3. So 3 goes into 3 once here, and it goes into 6 twice. So now, there are no other common factors. So I'm going to come up here with this. We have 2 left on top, and 1 times 3 to the 4th, or 3 to the 4th on the bottom. So that's what we should end up with for number 3. Now, the difference in the next block of problems is it says to evaluate. So now we have to simplify as far as we can. So for example, number 4, we all know that it starts off as 5 over 6 to the second. That's in exponential form. Evaluate means keep going. So 5 over 6 squared is 5 over 36. So if we're asked to evaluate, we simplify it as far as we can. If we're asked to leave it in exponential form, we would have stopped at 5 over 6 squared. Or, yes, 5 over 6 squared. All right, can I get all of you to do 5, 6, 7, 8, and 9? 5 through 9. So there is a big difference between write in exponential form and evaluate. Evaluate means we better not have any exponents in our answer. We have to keep going with the solution. Number 5 should be 8 over 3 cubed. If we were asked to leave in exponential form, well, actually we could do something about 8, but we're not asked to leave in exponential form. We are asked to evaluate, so this should be 8 over 27, and that's why it is 8 over 27. Number 6 starts off as 2 over 4 to the 4th, but we can do some simplifying in this one. We have a common factor of 2. And that would give us 1 over 128. Number 7, we're going to start off as 9 over 3 to the 5th. But we need to evaluate. We have a common factor of 3 right there. And then we can deal with the 3 one more time. And we end up with 1 over 27. Number 8, we start off with 16 over 4 to the 3rd. Expand the product. We have a common factor of 4, and then we have another common factor of 4 right there, and so we end up with 1/4. Number 9, that first part is -1. The opposite of -9 to the 0 power is -1, and so that's going to be -1 over 2 cubed. 2 cubed is 8, and so we can't do a whole lot there, so that's -1/8. Okay? All right, we got 2 more in that block, and then we'll go to the last idea for today. So go ahead and same thing, evaluate number 10 and 11. So number 10, 4 to the 0 power is 1, and so I simplified that first, and then I'm just going to take from there the same way we did the other problem. So we end up essentially with 3 squared over 5 cubed. No common factors there, and so it ends up being 9 over 125. Drew, how about number 11? We got to do a bit of work on this one, right?
Yeah, I don't know where to start.
You don't know where to start? Well, you should start like this. Right? Yes or no?
Yeah.
Okay. And then from there, since we're asked to evaluate, well, we need to now basically expand the product. Now start looking for common factors. And so from here we have a common factor of 3 between the 3 and the 6. And so 3 goes into 6 twice and 3 once. And then we could do that again right there. 3 goes into 6 twice and 3 once. But I still have now some 2's left in the numerator, and I do have some 2's left in the denominator. So I have a common factor of 2 right there. 2 goes into 2 once, and then I can do that same thing with the other 2. And so that's not the only way of dealing with this problem. One of the things that you could have done is you could have noticed, well, look, that 3 times 2 makes 6, and so that goes into 6 once, and that's 6 once right there. And then you could have done the same thing with that 2 and that 3. with that 6 right there. I mean, there are lots of ways of simplifying this thing, but you should end up with 1/3 when you are finished. Okay? Now, what happens if we have negative exponents in the denominator? Like this next problem, 1/3 to the negative 4 power. I know this one is not in your notes. It should have been in there, but it's not. So can you just kind of do this one off to the side? 1/3 to the negative 4 power. I want you to, with your shoulder partner, see if you can come up with what that would simplify to. I'll give you about a minute. Go. So once again, the question is, what does this simplify to? In math, we typically don't like to leave expressions with negative exponents. So we've got to do something about that. So 1/3 to the negative 4 simplifies first to 1/3 to the 4th. Well, that is a division problem. That means 1 divided by 1/3 to the 4th. And this is not the first time we've seen this kind of thing. In fact, this is, I think, the 3rd day of this kind of thing. That is the same thing as 1 times 3 to the 4th, which is 3 to the 4th. And then if you're asked to evaluate that, that would be 81. So that's kind of how we have to deal with this last group of problems. So right now, I would like all of you to do number 12 and number 13. So I didn't expect any issues with number 12, and I don't think I saw anybody get number 12 wrong. That one's pretty easy because it's just like the previous example. 1/5 to the negative 3 starts off as 1/5 to the 3rd, which is 1 divided by 1/5 to the 3rd, which is 1 times 5 to the 3rd over 1, which is 5 to the 3rd. And then if you're asked to evaluate, which we are, it is 125. But it is problems like number 13 that if you are not careful, this is where we have big problems. I'm going to do number 13 the same way I did number 12. This 2 to the 3rd over 7 to the negative 2, first of all, turns into 2 to the 3rd over 1/6 squared. And unless you are 100% sure of what you're doing, my advice, you write down the steps here. Because then you will see why, what some of you got, why it's really not correct. 2 to the 3rd over 1/6 squared is the same thing as 2 divided by, or 2 to the 3rd divided by 1/6 squared, which is, from the rules of dividing fractions, the same thing as 2 to the 3rd times 6 squared over 1, which is 2 to the 3rd times 6 squared. So if we were asked to write in exponential or leave in exponential form, we would be finished, but we're not. We're asked to evaluate. 2 to the 3rd is 8, 6 squared is 36, so that simplifies to 288. Any questions about that one? Number 14, 2 to the negative 2 over 7 to the negative 2. 2 to the negative 2 is 1/2 squared. 7 to the negative 2 is 1/7 squared. That is a fraction divided by a fraction. And when we divide fractions, we turn it into a multiplication problem, and then we end up with this before we evaluate. All right, so number 14, we are now asked to evaluate, and that is 49/4. Okay, 49/4 for number 14. Number 15, I'm going to go about this the same way. 5 to the negative 3 is 1/5 to the 3rd, and 3 to the negative 2 is 1/3 squared. So I'll do a little bit of simplifying with the numerator. 2 squared times 1/5 cubed is 2 squared over 5 cubed. So now we have a fraction divided by a fraction. And we turn all division of fraction problems into multiplication. And now we end up with this before we simplify to 36/125.